Good morning, Geometry Honor students. So Mr. Chen again. So today I would like to go over that sections 11.6. So volumes of pyramids and cones. So objective for the lesson today, find the volumes of pyramids and cones. So this whole unit, it's all about like formulas, three-dimensionals, figures, things that we need to find out. Surface area, lateral area, which is two-dimensional, volume, three-dimensional. So formulas for finding the volume of a square base pyramid. So it's always given as 1/3 times the capital B, which is the area of the base of the pyramid, and then times the height, the perpendicular height of the pyramid. So another one is that the volumes of a triangular pyramid. So the way to do it, so this one is written as 1/3 times the area of the base of that triangle, and then the height, capital H, that represents the height of the triangular base pyramid. Again, that height right there, it's always perpendicular. So back to the volume for the square base pyramid. So the other way to write it, it's 1/3 times s squared. S squared is just giving you the area of the square base. Okay, so the area of the square base, and then times the height of the pyramid. Okay, so the volumes of a cone. So that's another formula that you need to recognize. So it's pi r squared times the height times 1/3. So the reason why that is because that the volumes of a cone, it's just 1/3 of the volumes of a cylinder. So let's say that you do have a cylinder. Okay, like this. So the cone, it's always inscribed the one inside the cone. Okay, so just take 1/3 of that and you get the volumes of the cone. So here's the first example. Find the volumes of a solid. So this one 5, 5, 5, so it's a perfect cube. And then the other one, it's an upside down square base pyramid. So let's find the volume for the perfect cube first. So it's 5 times 5 times 5. So which is 5 to the power of 3. So which is 125 cubic feet. And then to find the volume for the upside down square base pyramid. So this one is 1/3 times the area of the base, which is 5 square, and then times the height, so it's given already, times 10. So it's 1/3 times 25 times 10. So it's 250 over 3. Nothing's divisible, it's not reducible, we just leave it as the way it is. So the total volume, then that'll be considered 125 plus 250 over 3. Convert that to the common denominator, so 3 times 125, which is 375, plus 250 over 3. So this one will give you 5, 2, 625 over 3. And the unit, cubic feet. Okay, so now let's see what else that we have right here. Find the following x. Okay, the radii of the circles. Okay, find the radii of the circle. Small radius, outer bigger radius. The volume of the small cone, the volume of the large cone, the volume of the frustum. Frustum is just the lenten right here. So we'll get to that. So let's just solve for x first. So we take out this right triangle. So this one is just considered a similar right triangle, proportionality. So what we notice is that the height over the slender height here, so a over x, it's the same as the ratios of the height of the entire cone, a plus 12, which is 20, over the sum of x plus 14. And then right here we can cross multiply, so 8x 14 times 8, which is 112. 4 times 8, that's 32. 1 times 8, that's 8 plus 3, 112. And then over here, 20x. So cross multiply, so we want to solve for x first. So ax minus 20x, or 20x minus ax, so what we got here, it's 12x. Divided by 12 both sides. Okay, so 112 divided by 12. Okay, so is that divisible? Okay, so let's do the long division. Okay, so 6 times 2, that's 12. 8 times 2, 16. 9 times 2, 18. Okay, let's try 9. 9 times 1, that's 9 plus 1, so 108. Subtract, so 4. Bring it down 0. So 3 times 2, 36. Keep going, so it's 9.333. So this one you can just round it up to, just leave that as a fraction. So it's 9 1/3. Which is 28 over 3, or just 9 1/3. So once we solve for x, so now you want to find out the radii of the circle. So using that, the Pythagorean theorem, so we can find out the radius of the circle. So the way to set it up, so it's r squared plus a squared equals 9 1/3 quantity squared. And then you just solve for r. Find the volume of the small cone. So that one is pretty straightforward. Finding the volume for the small cone is just using that formula. 1/3 times pi, whatever that r is, just plug in a number, quantity square, and then times the height. So the height would be 8. And then you'll get the volume of the small cone. And the volume of the large cone, so again, you can use the proportionality to find out that the capital R first, or you can use Pythagorean theorem. So using Pythagorean theorem, so it's R equals square root of 14 plus x. So 14 plus 9 1/3, which is 23 1/3 quantity squared. Minus the height, 20 quantity squared. So once you get that capital R, and then you can get the volume of the large cone. So again, volume, so 1/3 times capital R squared times pi, and then times the height. The height of the entire cone here, which is 8 plus 12, so then that'll be 20. And then the volume of the frustum, so the volume for the frustum is just the difference of the volume of the large cone minus the volume of the small cone. So the frustum, which is this shaded volume here. Okay, so just the length. So the volume for the large cone, so 1/3 r squared pi times 20, the one that you get from D, minus the solution that you have from C. So 1/3 pi little r squared times 8. And then you get the volume of the frustum. Okay, so now let's see what else that we have for this section. That's it. Okay. So again, so using all those formulas, the way to find the volume for the cone, the pyramid, or the triangular base pyramid, so we can get through those volume for the three-dimensional figures. Okay, so thank you for watching the video today. So I'll see you guys next week.